Okay, section 4.3 is the trig ratios. This first part isn't going to be anything new because we've done things with trig ratios in all your math classes that you've had so far. So just as a refresher, you might remember that sine, our formula or our ratio for that is the opposite side over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And we had a little trick or an acronym for this, and that was SOHCAHTOA. That was just something to help you remember how to, or which ratio went with which. Some new ratios, and I'm trying to recall them. I think in Pre-Calc 20 we did a little bit with the reciprocal functions. So the reciprocals are just basically the flip, right? If you think of a reciprocal in math, it's always flipping your value. So cosecant is the reciprocal of sine, and that means that its ratio is hypotenuse over opposite. Secant is the opposite of cosine, so that makes it hypotenuse over adjacent, and cotangent is the opposite of tangent, which makes it adjacent over opposite. Okay? As a reciprocal ratio, it's basically what we're doing is we're taking cosecant and saying it is the same as 1 over sine. So because sine of theta is opposite over hypotenuse, if I did 1 divided by opposite over hypotenuse, that's like saying 1 times hypotenuse over opposite. So 1 times, I have to do the flip of the second part, so that's where that comes from. So secant then is the same as 1 over cos. And cotangent, sorry, that should be theta. Cotangent is the same as 1 over tangent theta. Now there's a little trick for remembering which reciprocal function goes with which trig function. And if you look here, we have sine, and this has a co with it. This has a co, so it's just a secant. This had a tangent, so it has a co there. So there can, between the pairs of regular trig functions and reciprocal trig functions, there can only be one co. Okay? I'll just write that up here. Because a lot of time people want to put cosecant and cosine together because they're both cos, but you can't have two cos in a relationship. So a trick to remember, partners I'll call it, is that there can only be one, only be one co per pair. So sine can go with cosecant, but cosine can't go with cosecant because there's a co and a co, so that one doesn't work. So SOHCAHTOA becomes CHOSHAKAO. CHOSHAKAO. Sounds like it's a language of its own. Okay, so this one says, example number 1, find the trig ratios between negative pi and pi. Theta is between negative pi and pi, from a point 1/3 and 2 square root 2 over 3. So this is a little bit like what we were doing in the last section. So at the last section we were looking at unit circles. This isn't a unit circle, so we don't have an R of 1. So that means we have to do a little bit of calculating. So the first thing you always want to do is you want to draw this. where would this be? So I'm on the x and y axis. My x coordinate is a positive 1/3. So wherever I mark that doesn't really matter. It's just a sketch, but we'll say it's there. Negative 2 2/3 is going to be in the negative part. I'm just going to extend this a little bit. Of my y-axis, so I'm going to say it's approximately there. So my point would be right here. So if I were to extend this to make it into a triangle, it would look like that, and my angle theta would be right here. So I know that this value here is a 1/3, and I know that this value here is a negative 2 2/3, or negative 2 and square root 2. Let me try that again. Negative 2 square root 2 over 3. So where this is the same as last time is you do the same types of things. You identify your variables, and then you have to solve. So if my x is equal to 1/3, my y is equal to negative 2 square root 2 over 3, I don't know what r is. So I have to use my formula for the circle, which was x squared plus y squared is equal to r squared, and then just substitute to find the unknown value. So this becomes 1/3 squared plus negative 2 square root 2 divided by 3 all squared, and that's going to equal r squared. So this is 1/9 plus negative 2 squared is 4, square root 2 all squared is 2, and 3 squared is 9. So I have 1/9 plus 8/9 is equal to r squared. So that becomes 9 over 9, which is just 1, and 1 squared equals 1. And because this is a hypotenuse, there's never a positive negative, it's always positive. So that means for this particular one, now that I have my x, y, and r, I can find my trig ratios in between negative pi and pi. Okay, so starting at sine. I'm going to run a little bit into this one, but that's okay. So sine of theta, excuse me, I got to sneeze. Sine of theta is opposite over hypotenuse. So opposite is negative 2 square root 2 over 3. Hypotenuse was 1, so it's divided by 1, so it's just negative 2 square root 2 over 3. Cos of theta is adjacent, so that's 1/3 over hypotenuse. So it's divided by 1, so it's just going to stay that way. My tangent is opposite, so that's negative 2 square root 2 over 3. And my adjacent is 1/3. So that means it's negative 2 square root 2 divided by 3 times 3 over 1. So those cancel, so it's negative 2 square root 2. So my reciprocal functions then are just going to be the flips of those. So for sine, my opposite is cosecant. So that's going to be 3 over negative 2 square root 2. But I can't leave a square root 2 in the bottom. So that means I have to rationalize the denominator. So I multiply by square root 2 over 2. So that's 3 square root 2, and I'm going to put my negative on the top, over 2 times square root 2 times square root 2 is just a 2, so that becomes a 4. So negative 3 square root 2 over 4 is my answer for cosecant. Secant, then, is the opposite of cos. So if I flip that one, it's going to be 1 over, or it was 1 over 3, so it becomes 3 over 1. Tangent becomes cotangent. So that becomes it was negative 2 square root 2 over 1, so that becomes 1 over negative 2 square root 2. I rationalize my denominator on that. It's going to be negative square root 2 over 4. Okay, next one. I'm just going to put a line here so we can see. Maybe I'll do it in red so we don't mix the two up. So ratio's sine of theta is equal to 21 over 29. So they didn't give it as a point, they gave it as a fraction or as a ratio. So I know that it's that it's 21 over 29, and I know this is opposite over hypotenuse. When we're dealing with theta, and we're going to talk about this one a little bit more, but if we look at when we're dealing with theta, our opposite side is always our x, or sorry, not our x, our y value. The hypotenuse is always the r value. So I know from here I've got my y and my r value. I need to find my x. So I have x equals don't know what, y was equal to 21, and my r is equal to 29. So using my formula, I'm going to calculate my x value. So x squared plus 21 squared is equal to 29 squared. So really what I'm doing is x squared is equal to 29 squared minus 21 squared. And if you calculate that, that equals 400. So square root, x is equal to plus or minus 20. And I need to include that plus or minus 20 because I could have two possible solutions to this. Because it didn't give me a specific point like that the first one did, I have to plot both of my, or sketch both of my possibilities. So if this is my Cartesian coordinate plane here, my one coordinate could be at negative 20, 29, sorry, 21 I mean, that's my y. Or it could be at positive 20, 21. So negative 20, 21 would look something like that. That's a positive, so this would be 20, this would be 21. Or it could be going this way at negative 20 and 21. So I have two possibilities. So that means that when I do this, I'm going to have two sets of values for each trig function. So they've already given me sine of 21 over 29. So I know that my cosine then, sine was 21 over 29. My cosine, my reciprocal function, is just going to be 29 over 21. There's only one possibility for that. I don't have to do, because I'm not using the x value, I don't have two possibilities. So cosine of theta, cosine, if this is theta here, cos is equal to adjacent over hypotenuse, so that becomes negative 20 over 29. But I could also do the other value, which was the positive 20. So I can do those as a 2 for 1, plus or minus 20 over 29. So the opposite of that is secant theta. Secant theta means that I'm going to have 29 over 20, and I'll just put my plus minus in front because I shouldn't put it in the denominator. Tangent theta then, tangent is opposite over adjacent, so opposite is 21 over 20, and that's going to be another plus or minus, because I could have a positive 21 over 20, or I could have a negative 21 over 20. So my cotangent then is the reciprocal of that, so it's going to be plus or minus 20 over 21. So if I were to write these out each individually, I would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 solutions that I need for that particular problem. Okay, finding the approximate value with your calculator. So when you're doing these ones, you have to watch what your calculator is in and what the question is asking. So if there's a degree in the question, then your calculator needs to be set at degree. If there's a radian or a pi value in there, then you have to have your calculator set to radians. And that is just a matter of changing your mode. So when you turn your calculator on, you hit the mode button, which is right beside the second button, and you have normal science, engineering, floating, radian, degree is the third choice. So for example number 1, cos of 125, I need to move down and change that from radian on my calculator anyway, and make sure it's on degree. Okay? So calculators need to be in degree for these. So on your calculator, it's just a matter of punching in cos 125. Right, it was 125. So I get my answer. So it worked out to negative 5,736. And whenever you're doing these, you need to make sure that you are always rounding it to 4 decimal places. Okay, secant. So you'll notice on your calculator you don't have a secant button. So there's a couple of ways of doing this. The first way is you know that secant is the same as the reciprocal function for 1 of cos of theta. So that's the same as saying on your calculator this would be 1 divided by cos of 327 degrees. So if you punch that in, you get 1.1924. And again, I round it to 4 decimal places. If on your calculator you tried to go second function secant, you'll notice that you'll get an error. You'll have cos to the value of negative 1,327, and that's because you can't do a reciprocal with your calculators in that function. That's not doing a reciprocal. There's another word for it that I just forget. So you have to change it into a reciprocal function in order to do it. Okay, cotangent of 9 pi over 7. So again, you have to change your calculator for this one to radians. So if you hit mode, go down to the third choice. I want radians, select enter, and then you're, oops, good to go. I just hit the wrong button. Okay. So we're going to try cotangent of 9 pi over 7. So I know cotangent is the same as 1 over tangent theta. So that means I'm going to do 1 divided by tangent of 9 pi over 7. So 1 divided by tangent 9 pi, and pi is right underneath. It's the second function of the button right under clear, that little caret. And you should get 0.7977, and if you round it, it'll be a 5. 0.7975. Okay, and the last one here, cosecant. Cosecant is the one same as 1 over sine of 17.2. So that's in radians. If there's no degree value in there, then you know it's a radian. So I do the same thing. 1 divided by sine of 17.2, and you get negative 1.0031. Okay, so that's for calculating approximate values. Okay, next example says, which quadrant could an angle be located if sine of theta is greater than 0 and tangent of theta is less than 0? So there's a couple of things that you have to remember, and that is the cast rule. And the cast rule, if you remember from last year, tells us which quadrant our trig functions and their reciprocals are positive. So cast rule looks like this. You have your quadrants. We have C, A, S, T. So C stands for cosine, and secant would be positive here. A means all of them, so all 3 trig ratios and the reciprocals. S stands for sine and its reciprocal, which is cosecant, and then tangent and cotangent. Okay, so that helps you just to know which quadrant these would be positive in. So if we do our cast rule for this one, this is saying when sine of theta is greater than 0. So sine of theta is positive. So sine is positive, according to this, in this quadrant and in this quadrant. So this is for sine. Tangent theta is less than 0, so that's where tangent is negative. So tangent is positive in quadrant 1 and quadrant 3, so it's negative in quadrant 2 and in quadrant 4. So where are both of these restrictions possible? Well, right here. So which quadrant could this angle be located in? This would be in quadrant 2. Okay, the next one is for cos theta is less than 0, and cosecant of theta is less than 0. So remember, cosecant is the opposite, or the reciprocal function of sine. So that's the same as 1 over sine. So I'm looking then, when I do my Cartesian coordinate plane for this one, sine is negative. According to my cast rule, it's negative in quadrant 4 and in quadrant 3, because that's only cos and tangent are positive there. And cosine cosine is negative in quadrant 2, because only sine is positive there, and in quadrant 3, because tangent is positive there. Cosine is positive in 1 and 4. So this one works in quadrant 3. Another trick just to help you when you're doing some of these questions is to remember our other trig ratio that we did. And it's not really the other trig ratio, but instead of using opposites and adjacents, when we're dealing with the coordinate planes, we're referring always to our points x, y, and r. So if you remember, we had, I'll just draw it this way. If this is theta, this was x, this is y, this was r. I'm just going to do this in groups. So our sine of theta, sine is opposite over hypotenuse, so it was y over r. Cosine of theta is adjacent over hypotenuse, so that's x over r. So instead of using opposite, adjacent, and hypotenuse, we're using the values from the Cartesian coordinate plane to get our values that we substitute in. And then the last one was tangent. So tangent is opposite over adjacent. So that's y over x. And our little acronym for that, you might remember, was SIR, Kixer, Tix. So this one helps you too when you're doing questions like this example that we just finished, where you're trying to figure out which quadrant things are positive in, and then also when it comes to finding values. You can make yourself a little chart. Oops, sine, cosine, and tangent. And then, of course, this also applies for the reciprocal functions. We just use the primary functions, and then we just do the flips on them. So if you remember when back in, I think it was in the first section, sine of theta we said is the exact same value as our y coordinate. Okay, when we're looking at the unit circle, if it was opposite over hypotenuse, so sine is opposite, which is y, over hypotenuse on the unit circle, which was 1, so it was the exact same as the y value. Cos of theta is adjacent over hypotenuse, so that is the same as the x. And our tangent was cosine, no, I had that right the first time, sine over cosine, or opposite over adjacent, which is just y over x. So this helps us when we're looking at where things are positive and where things are negative. So in quadrant 1, we did a little checklist. Remember in quadrant 1, we have the A value there. So that's for A, so all of them are positive here. Sine is positive, cos is positive, and tangent is positive. In quadrant 2, quadrant 2 has the S. So in quadrant 2, only sine is positive. So that means that this would be a positive, so our y value would be positive, our x would be negative, and our y over x, oops, I forgot my bar in between there, would be negative. Quadrant 3 has T for tangent. So tangent is positive, but our x and y values, or our cos and our sine values, are negative. Because if you think about this, for tangent cotangent is in this quadrant here, so if you were to draw a triangle in here, you'd have a negative x value and you'd have a negative y value. So that means you'd have a negative cos and you'd have a negative sine. That negative divided by negative to get your tangent makes it a positive. And then the last quadrant, oops, that's a bad looking one, is our c value. And that means cosine is positive. So in this quadrant right here, you have a positive x going this way, but a negative y going down. So we know that y's or sine, or the y value is negative, the cos or the x value is positive, and you're going to have a negative tangent value. So that little trick, the sir kicks or tick, and then the cast rule is helpful when you're answering questions like the ones that are going to follow, where they want you to find the exact value of a trig ratio using the special triangles. So remember, your special triangles are those 30, 60, 90 triangles and the 45, 45, 90 triangle. Okay. So this one says, find the cotangent of 270, find the exact value of a trig ratio using your special triangles for cotangent of 270 degrees. So the first thing we're going to do is we want to draw this. We want to see which quadrant is this going to end up in. So I know if I go around to here, that gives me, where am I, 270? It's a positive. Right there, 270 degrees. So this is where I'm ending up. If I think about my unit circle, going all the way around here, because it's special triangles, we're using unit. Okay, unit circle. So I know on my unit circle, this point right here, if that's where I'm going to, is going to be 0 on my x and negative 1 on my y. So cotangent of theta is equal to, it's the same as my 1 over tangent theta. And tangent of theta was y over x, so that means cotangent is going to be x over y. So I know from here my x is equal to 0 and my y is equal to negative 1, so tangent of theta would be 0 over negative 1, or sorry, negative 1 over 0, which is undefined, but cotangent of theta, so cotangent of theta is 270 degrees, is x over y, which is going to be 0 over negative 1, so it's just a value of 0. So this one I didn't actually need my triangle, I am just going to use my, because it's a unit circle, because it's on the unit circle and it ended up right on one of my axes, then I just use 0 and negative 1. Okay. So for my next one here, I have secant of 5 pi over 6. So again, first thing I do is I'm going to draw my coordinate plane, my unit circle. Oops, 5 pi over 6. I know when I do this, this is 6 pi over 6 is here. This was 3 pi over 6. So 5 pi over 6, it's probably actually a little bit closer down this way, but I'm just doing an approximate, so it's going to be about right here. So this is theta right there. So that means I need a reference angle in this case. So my reference angle, because I'm in quadrant 2, is going to be my pi minus that. So 6 pi, this is my reference angle, 6 pi over 6 minus 5 pi over 6, so that leaves me with pi over 6. So that's the reference angle that I'm going to be using when I do this. So pi over 6, if I think about my special triangles, pi over 6 would be here, which is the same as my 30 degrees. Pi over 3 would be up here, which is the same as your 60 degrees, and then my 90-degree triangle. So when I was doing this on the unit of 1, this was 1 here, this was 1/2, and this was square root 3 over 2. Now if you can also do this, and for these ones it'll work, if you didn't divide all those by 2. You could leave them just as 2 square root 3 and 1, and you can still calculate the same values. Okay, so I'm just going to put that in brackets. This could be the same as 2, 1, and square root 3. So for pi over 6, I know that I'm going to use my... Oh, I have to sneeze again. I'm just going to pause for a sec. Hey, sorry about that. I just have to fix one thing before I go further. I did my ratios here. I mixed them up. Pi over 3, or the 60 degrees, should have the square root 3 over 2. Oh, I should do that in blue, sorry. Square root 3 over 2. And the pi over 6, opposite of that one, or the 30 degrees, should have the 1/2. If we were to divide all these by 2, then this would be 1. I'm multiplying by 2, sorry, to get rid of that. And this one would be square root 3. So it doesn't matter which ratio you use. If you use the unit of 1, then you'll have 1 1/2 square root 3 over 2. If you're using the value of 2 for the hypotenuse, then it's 2 1 square root 3. Either way is still going to get you the same answer. Use the one that you're most familiar with. Okay, so pi over 6 is what we're looking at. So I want to find secant of pi over 6, because that's my reference angle. So I know since this is in this quadrant here, and I'm just going to draw my triangle a little bit bigger so you can see. So this is my angle theta, which is pi over 6. So opposite of that, I have 1/2. And adjacent to that, I have square root 3 over 2. But because it is on this side here, I know it's a negative x value, so that has to be a negative in there. So secant is the opposite of cos. So cos of theta is equal to y, because it's the, x over r, because it's the Kixer. So I'll move this back up. Where was that? It's this. C is equal to xr. So I know if that's my c, or if that's my cos, then my secant is going to equal r over x. So my r is a 1. My x value is a negative square root 3 over 2. Now I know I can't leave it that way because that's just wrong. So the first thing I'm going to do is I'm going to change this, so it's going to be 1 times 2 over square root 3, and that's a negative. So that's just going to be negative 2 over square root 3. But I can't leave a square root 3 there. I have to rationalize my denominator. So this becomes negative 2 square root 3 over 3. And that's my final answer. Now I'm just going to show you if I had done this so that I didn't use fractions in here, if I didn't use the unit of 1 for my R value, if I had used my doubled values here. So if I go back to this one, my triangle would look, on that circle, it would look like this. I would have square root 3 here, I would have a value of 1, and I'd have a value of 2. So my secant is R over X. So it's still R over X. My R value is 2. My X value is that negative square root 3. So I just rationalize my denominator. So I get negative 2 square root 3 over 3. So you can see how I get the same value, whether I use the unit 1 with a radius of 1, or if I use the value where I'm not working with fractions for my other values. Okay, the last one here, sine of negative 4 pi over 3. So again, I need to draw this, and I'm not going to worry about drawing the circle around it. So I know negative means I'm going in a clockwise fashion. So this would be 0. This is pi, or in this case I have a denominator of 3. So that's going to be 3 pi over 3. So I need to go another 1/3 pi past that. So I know it's going to be somewhere in here. Maybe not exactly there, but close enough. So I'm going in this direction. So this is going to be my triangle. So if it's in this quadrant, I'm going in a negative. I know to go from here to here, I'm going to have to do some subtracting. So I have my 4 pi over 3, and I subtract my 1 full pi, so that's 3 pi over 3, to get pi over 3 as my reference angle. So I know then if this is a pi over 3, I'm looking at my 30, 60, 90 triangle here. So opposite of that, and I'm just going to use my non-fraction one, or my not unit one. So I have a square root 3 as this value as my opposite value. My R is going to be a 2. And my adjacent, my adjacent side is this one here, so it's a 1. And because it's over in this quadrant, that means that it's going to be a negative 1. So looking at this one, my x is equal to negative 1, my y is equal to square root of 3, and my r is equal to 2. Okay, and I know when I do this, my value, because if I look at the cast rule, C-A-S-T, well, sine normally is not going to be, or sine isn't going to be negative because I'm in a sine positive quadrant. So we'll see when we finish our answer if we get a positive value for this. So I'm going to do sine of my reference angle. Oh, sorry, this was reference angle here. So my reference angle is pi over 3. So sine of pi over 3, whoops, sine is equal to, it's at SIR, so that's y over r. My y was square root 3. My r was 2. I don't need to rationalize the denominator. I have a positive value because I'm in quadrant 2 where sine is positive, so I know I'm all right. I'm just going to draw your other special triangles here. The other special triangle in our fraction state. So for the 45, 45, 90, or pi over 4, I can't make pies. I can't make pies. Pi over 4, pi over 4, this was 1, 1 square root 2. When we were looking at it in the other section, we did it on a unit circle, so we needed to have our radiuses or our hypotenuses as being 1. Because this doesn't say we're on a unit circle, we don't have to do that divide by. So when we did do it, this was 2 square root 2 over 2, because we divided everything by square root 2. This was 1 over square root 2, or 2 square root 2, and this was the same thing. On a unit circle, or sorry, not on a, well, I guess on the unit circle, when they are exactly on one of these axes, we know that our values are going to be, so this point was at 1, 0, this was at 0, 1, this was at negative 1, 0, and this was at 0, negative 1. So this was for the values of 0 and 2 pi, this was for pi over 2, this was for pi, and this one was for 3 pi over 2. Okay, so that's just a refresher from the stuff on the last section. So that's all. I took a little bit longer just doing a little extra, a few extra explanations there. Good luck.